Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Compass Circles by Marty Sears. And here are the rules. Fill the grid with the digits 1 through 5 and the letters N, E, S, and W, which is north, east, south, and west, so that no digit or letter repeats in any row, column, or 3x3 box. So this is a variant of normal Sudoku rules. Instead of 6 through 9, we have north, east, south, and west. But you cannot have repeats in any row, column, or 3x3 box. A small white dot sits between two digits that are consecutive. So, for example, if this were, say, a 4, this would have to be 3 or 5 to be consecutive with the 4. Each purple circle contains a letter and has an invisible straight arrow attached to it. Arrow lengths are to be determined. So every purple circle has a letter in it, and they have an arrow pointing in some direction that is straight. The letter in the circle indicates the direction of its arrow points towards, and you can only point north, east, south, and west. The invisible shafts of the arrows may only contain digits, and each arrow shaft has the same total to be deduced, and arrows may not share cells. So we have to have something attached to this, so we have to have something like going out from this, and it could be in north, south, east, or west. We do know that if it's N, the arrow points north. If it's E, the arrow points east. If it's south, the arrow points south. S, if the arrow points south. And W, the arrow points west. So the letter that the circle has is the direction of the arrow. And first of all, the shaft of the arrows can only contain digits. And each arrow shaft has the same total, or the same sum, which we have to deduce. And you cannot share cells amongst arrows. So you cannot have something like an arrow going this way and then an arrow going that way, because then there would be sharing cells. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, in column 5, we have 4 circles, which must be equating to north, east, south, and west. Now, the thing is, the only thing that can go north is this direction. So this must be a north. So that means we know this goes at least this way. We have to have a south here, too. So, and the only one that can go south is here. So this is south, and it has to go this direction. And then we have east and west here, which we're not sure of. Okay. And remember, these are the digits 1 through 5. So we have at most 2 digits here. So that means we have a sum of 9 at most. This cannot go this way. This can't go north because of the north in the box. So this is east or south here. Let's do all the possible combinations for the letters. This can go south and east also. East and south. This can go any direction but north, east, south, or west. This can go north, south, and east. This can go north and east. This is an ENS combination in column 1, or triplet in column 1. This cannot go south. It can go north. It can go east or west. This can go specifically north, no south, or west. This can go west and south. This can go north and west. So we have a northwest-northwest combination here in column 9, which eliminates north and west. So this is south, which means this can't be south. That's east. This can't be east. This is north. This can't be east or north. It's south. Interesting. This north eliminates north here, so it's west, which makes that north. Okay, so this cannot be north here. Cannot be north here. Cannot be east here. So it's south or west. North or west. North or west. Okay. This combination cannot be north, cannot be south, so it's east or west there. Interesting. So if this is east, this would have to be west, but then they would share a cell. So this cannot be east. This is west, which makes that east. West eliminates west there, so that's east. This can be any of the directions, northwest, east, south. This can't be west or north. No west or north, so this is east. Which means this cannot be east here. This cannot be west. It could be north, south, or east. Okay. We have news. Anyways, this goes east, this goes west, this goes east. North goes that way, south goes that way, east goes that way, south goes that way, north goes that way, west goes that way, east goes that way. So one of these has to be a single arrow. So that means the sum is 5 at most. It can't all be 1 or 2. They have to be the sum of at least 2 unique digits because these digits are different. So that means it's a sum of up to 5, which means it can never be 3 digits. It's either 1 or 2 digits that it's equal to the sum of. Interesting. Okay. Where is east? East has to be in one of these 2 cells in box 4, in one of these 2 cells in box 2. No east there. Okay, south has to be one of those 2 cells. West, don't really have that many restrictions there. North, don't really have that many restrictions there. These are consecutive digits, so they have to be digits. These have to be digits. So these are all digits here. Okay, let's mark the digits only as blue. Oh, this is a singleton digit. Because it goes east, it cannot share, so this is done here. So whatever digit is here is the singleton digit. This must then be 2 digits to add up to that. This can't be the singleton digit. It must be 2 digits there. So we'll mark those digits as any digits as numerals as blue. And I guess we'll mark all these as red. Okay. Oops, I should not have deleted that one. Anyways, this is northwest or south. This cannot go west because it would share a cell with that, so this is north or south. This has to be 2 digits. We have 3 unique digits, which are going to sum up to this. So the pink has to be 4 or 5. Well, it can't be 4. This has to be 5. So this has to be a 5 here. So the singleton digit must be a 5. Which means this cannot be 5 here. One of these two is a singleton digit. We don't know which. So one of those is going to be a 5. I guess we should just remove those. This can't be 5, so it's 1 through 4 there. Let's see. This can go east or it can go south. If it goes south, this has to be a 5. Oh, but if this goes south, this has to be east. And you can't have a letter on the arrow. So this cannot be south. This must be east then. So that's east, which means it goes this way. 5 cannot be either of these. 5 can't be either of these. These have to be a different set than these 2 digits. So let's mark these as green. These will be the blue set, adding up to 5. This can go east or west. If this is going west, that's possible. So one of these is a 5 then. One of these is a 5 because it can only go one that way. It can only go one that way. This can go south or west. This can go north or south. Okay, so one of these is a 5 because it can only go one this way or it could only go one that way. So this cannot be a 5, which means this must be a 5 here. So this is 5. So that's done there. This is 2 as a digit. You cannot have 5 here. No 5 here, no 5 here. This has to be 2 digits. So this is blue. We have to have a 5 somewhere in row 9. Well, it can't be these. It's one of these two. So 5 in row 7 has to be one of those two. Well, this cannot be 2 digits then. Because if this were 2 digits, it would be 5 plus another digit, which means this is a singleton digit. So this is 5. This is done. This has to go 2 here, then 2 here, because we already have a 5 in the column. This is blue also. We don't know which coloring that is, though. Let's make these specific. This is orange. This is 5 or it's green, going this way. East cannot be any of these. East has to be one of these two. This can't go south. It would be sharing its cell with this arrow. This can go east or north. It cannot go east, though. That would be a singleton digit, so this has to be north, which means this goes 2 that way. Cannot be orange as a pair. Actually, could be. We don't know which one these are. These are blue. This is north. North cannot be either of these. Where's north in column 7? It must be there. Now we have west. West can't be either of these. North can't be here. North can't be one of these. So north has to be one of those two. Therefore, these are definitely digits. We have digit here, and digit here. These are all digits. West is one of these three. Not too helpful. South can be any of these three. Also not too helpful. If this is south, it has to go 2 digits because we have a 5 in the box, but then we would have 6 numbers in the box. So this cannot be south. It must be north. It has to go this way, and it can't. One of these is a 5, so it has to be 2 digits that way, which means this cannot be north also. This is north here. That's red. This is blue. This cannot be 2 greens, so this has to be 2 oranges. This could extend. We don't know. Therefore, we have all the digits here. This must be a letter, and it's north. Okay, where's the north in column 3 then? Actually, we should have 8 norths, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes, we do. We know where the last north has to be. It has to be there. We still don't have that much other information. South cannot be here. These are all digits, so south has to be one of these two, which means this can't be south. So south must be there. One of these has to be green. We don't know which. These are guaranteed to be numbers. This can go south or it can go west. If it's south, it has to be 5. If it's west, that's fine. These digits add up to 10, and so they have to be different than these. So we'll mark these as yellow and these as medium. This could be... Oh, wait, can't be orange. This has to be 2 greens. So this is green, which makes this orange. Okay. This green has to be one of these 2 greens. This cannot... We have all 5 even numbers, or numbers in column 8. So this has to be a digit, a letter. This can't be east then, which makes this east. That leaves that as west. This is a number here. This has to be orange. These are 2 oranges. It could have orange and green. We don't know which. One of these is a letter and it's east. One of these is a letter, it's south. One of these is a letter, it's west. We have the green and the west here. So this could be 2 digits. Could be a 5. This could be 2 digits, or it could be a 5. This will mark as, I guess, medium, and this will be yellow. This could be a 5. These are all digits. We have 4 digits here. So we have... Okay, this cannot be 2 letters. So if we have that as a digit, this would have to be 2 letters. We'd have 5 letters in the box. So this has to be a letter here. Which means this is a digit-letter combination. One of these two is a letter, which means both of these are digits. Interesting. Let's see. One of these is west. If this is west, this would have to be east here. It would be west pointing that way, so this cannot be west. This must be east. So this is east pointing this way, which means this is the 5. We don't know what this is. This points east to the 5 there. This cannot be 5, so it must be 2 digits. So it goes that way, which means this can't be west. This has to be a green pair. So that's both greens. This has to be red and a west there. This is a digit. We don't know which. 2 orange, 2 green. So 1 orange here. Five has to be one of these 2 digits here. If this is south, this would be a 5. One of these is a 5, but this can't be 5 there, so one of these 2 is a 5. 5 can't be here. It's one of those 2. 5 is one of these 4. This has to be a orange-green combination, but we don't know which one this is. Okay. This can't be or... So if this is 5, that would force this to be 4. Therefore, this could not... I guess that could work. That would be 2, and this would be 3. So how does that work? Okay, so if this is 5, if we have a 5 here, that would mean this is 4. This would have to be 2, 3 as a pair to add up to 5. So then this would have to be 1. So this would be 2, that's 3. So that's how that would work. If this is not 5, say this was 5. If this is 5, then that becomes 4. This has to be 2, 3 as a pair. And that doesn't work. Hold up. No, that's not how it works. If this is 5, this is 4, which makes this 1, 4, adding up to 5, which makes that a 2. And then this is a 3. If neither of these are 5, that means this goes that way, this goes that way. So this has to be 5. This is 4 and 1. And therefore, this would be 2 and 3. So this is always 3. So this is always 3, which means the orange has to be 1, 4. Which means the greens are 2 and 3. Okay. We know a 1 is guaranteed to be one of those two. Interesting. So this cannot be 1. It's 2, 3, or 4, which makes this 1, 2, or 3. Okay. We need west somewhere. In column 6, it can't be here, it can't be here, so west has to be one of these two. South. South can't be here. South can be any of these 3. So that's not helpful. This is south or west. We don't know which. This can't be, right, it's a digit. So this can't be 5. It's 1 through 4. This is a different digit than both of these. Though I guess this could be this. No, okay. So can this ever be 2? If this is 2, it can't be this pair that adds up to 5. It can't be that digit, which adds up to 5 with the other digit. So this can't be. This has to be pink. So this is 5, which means this can't be 5 here, which means we have to have a 5 here. That means we can no longer have west here, so west has to be here. These are both then letters. So this is west, this is south. That's a digit, so that's the green digit, which is 2 and 3. This can't be green, so this must be the orange set. This can't be orange, it's the green set, which means this is orange. So this must be 1 and 4. No 1 or 4 here. It's 2 and 3 as a pair. These are both green. That leaves this as a red digit. Oh, yeah, we already sort of knew that. Well, we didn't really know that. We knew one of these was red. This has to be orange and is 4. This can't be 5, so we know we have a 5 here. It should be... No, we don't know where the 5s are, though. This can't be 5, so one of these is a 5 here. So if this is 5, that's 4. This 4 eliminates that from being a 4, so this is 1, which makes that 2. So this can't be 2, that's 4 and 5. So this continues there. This is done there. This can't be 5 anymore. Where is the 5 in the box? It must be here. That leaves this as an east. This is south or west. Oh, this, well, could go either way. This cannot go west, though, because that would be 1 and 2 as a pair. So this must go south. So this is south, that's west, that's south. So that goes this way. Remaining digits are 3 and west here. So this is 3 and west. Remaining digits here are 1, 4, and west. Remaining digits here are 1, 2, 3, 4. One of these, so this is 1 or 2. This is 1 or 2 guaranteed here, which means this can't be 1 or 2. It's 4 or W. This cannot be 2 greens because we have 2 greens already in the row. So this has to be 3, 1, and 4, which eliminates 1 and 4 in the rest of the column. This can't be 4, it's W. This can't be 1, it's 2. This can't be W, it's 3. which makes that W. This can't be W again, so it's 1 or 4, which means this can't be 1 or 4, it's 2 or 3. 2 eliminates 2 here, so that's 1, which makes that 4, which makes that 1 and 4, which makes that 1 and 4. So this is orange. One of these is south. These are both orange digits, so we have 1 and 4 here. This is 2 and 3 here. The remaining digit, we have all 5 numbers in row 7, so the remaining digits are letters. So this can't be a letter here. This is the other green. This must be south. We have east and west left, and this can't be east because of east in the column, so that's west. This is east. These are letters. This is green. We have orange here. We have a letter, which is south, which cannot be here in row 8. So this is the letter. That's south. This must be the orange, and it cannot be 4. So then this becomes 1, 4, 1. 4 is consecutive with 3, so that's 3, that's 2, which makes this 3 and 2, which makes that 3 and 2, which makes that 3 and 2. 2 eliminates 2 here, so it's 3 and 2. This is the only 2 remaining. 1 eliminates 1 here, so it's 4 and 1. That 1 eliminates 1 there. This is green. This has to be orange, and this is green here. So we're left with a green here and a green here. So this has to be 3, which makes this 2, which makes that 3. 4 eliminates 1, 4 here, so it's 1 and 4. And that's a solution. Pretty cool. A nice little variant on normal Sudoku. Especially with the north, east, west, south. That was very interesting. Yeah, overall, just a very interesting variant there. Hopefully, yeah, we'll get more of those types of variants. That was actually a very cool, different variant than we usually have in Sudoku. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.